Based on what I saw in the discussion about Schoology, I want to take a few minutes to talk a little bit about the results of the Pendulum Lab you did to help set you up for the next step of the activity. Now, the first question in the discussion is which variable affects the period of a pendulum? And there was really strong agreement that length is the one that matters. And so I have on my screen some data I collected of period versus length and that I plotted in Desmos. So people noticed that when you had the period versus angle and the period versus mass graphs, you got something fairly close to a horizontal line. It wasn't perfectly there, but it was close. And so that no matter what angle you had and no matter what mass you had, you got about the same period. So that variable does not matter. Now the next question that we asked you was what should be the intercept on this graph that does matter? And there was really strong agreement that the period versus length graph should have an intercept of 0, 0, which makes sense. If you have a pendulum that doesn't have any length, it shouldn't take any time at all for it to swing back and forth. So we expect an intercept around 0, 0. Now what tripped people up is what shape the graph seems to be. So I'm going to go ahead and turn on a linear fit. Now this linear fit looks pretty good. My dots fall really close to that line. If I look at the r squared, which is just a statistical measure of how well this line describes my data, I get a number pretty close to 1, where 1 is the ideal value. If all of my dots were perfectly on the line, r squared would equal 1. So the statistics tells me that this is a pretty good fit. But if I look at my intercept, it's about 0.6 seconds. And that's actually bigger than that's actually right around some of the periods that I measured. That 0.6 seconds, when I'm looking at a range of up to about 2 seconds for my period, that's a pretty significant intercept. That's going to be too big for me to ignore. And so that tells me that this linear fit probably isn't quite right, even if it looks pretty good. And that's something that's pretty common. If you're looking at a fairly small range of values, like looking only over a 1 meter range of length, you can have data that has a little bit of a curve to it that looks pretty linear and where that linear fit works pretty well. But a lot of times that intercept is going to be a big clue that that linear fit is not quite right. So what I want you to do is either add or imagine adding a point at 0, 0, and then imagine tracing that line going from 0, 0 up through your other data points. And then look at that common physics relationship sheet to try to figure out which of those relationships is closest to what you have if you include a data point at 0, 0. And that's going to tell you what you need to do to linearize.